Hello. Can you see me, hear me? Can you see
Yep.
my desktop?
Not the desktop yet.
Not yet. Okay. Sharing it now. There we go. You should see my desktop with
Yep.
nothing on it yet. You should now see my my notes coming up soon. And we should start in just a few. So we have who's here? We have Kenny and Jessica. Hey guys. So, did you succeed or find time with playing with your domain at all? With the static site thing that we discussed at all? Anybody? Any of you?
No, not with the holiday weekend. It's on my to-do list. I promise.
Don't worry. You know, focus on priorities in life should be very clear. I should, maybe give you a couple of things. I'll tell you my priorities in life. Family, then work, and then fun. Those things happen. But the Cloud Genius Bootcamp is not in the top 3. just kidding, right? Just kidding. So I'll let you decide what your priorities are, and accordingly you do your thing. There is no reason to spend your weekend time on a domain and DNS and other things, which is kind of nice, but priorities are important. So I'll let you figure that out. Not going to superimpose, my thoughts on what your priorities should be, because I don't do that. But I'll tell you what I did, and what I want you to do, so you can decide whether you like it or not. So let's quickly recap, and what I want to do is we have a lot more that I want to cover, and I would like to go over that in the cloud technology segment that we have. I want to cover a bunch of things that we already know. We have been discussing the storage elements, right? Briefly, if you recap that, we have been discussing primarily focusing on storage pieces. We have 2 big things to cover, which is the compute part and the network part. The network pieces are really, really, really complex and difficult to comprehend. This is really makes it difficult because many of us are not, networking background. And then more importantly, all of these things are defined in software, meaning we are going to interface it with 3 different things, like a web browser UI, API, or a command line interface. That's what the tools we'll use to interface through our software to program these capabilities in the context of cloud. So we want to focus here. We are doing that. We'll switch over here and then go to the networking capabilities in the context of using cloud in multiple cloud providers. But I want to do this guy full justice before I switch to this topic. And so that's what I would like to spend some time on, ideas related to DNS, finishing off a couple of other finer aspects in using the storage capabilities provided in the cloud, so we get a good understanding of concepts that we will then put to use in the subsequent segments, like the DevOps segment and also the architecture segment that are coming up. And so that's what I want to focus on, is to make sure that I cover all the bases, so that as we go deeper with the variety of capabilities, that we really, really understand these things and put them to real practical use. That's our goal. If you have audio problems in hearing me properly, please let me know, because I forgot to put my microphone in the right spot. That may be causing a little bit of echo, but maybe not. But I just forgot, so I should just put it back in the right spot. Right there. And we proceed. So let's see what we did in these storage elements, and we'll couple that with DNS aspects. Now that we have a domain name with us, we have, a couple of us have succeeded in creating fancy new structures that I would like to highlight and showcase. Like, for example, our friend, Mr. Sridhar Kura, has done, let's show it to everybody, Cocktails with Chloe.
Kura. Not Chloe. I wish.
I know, I'm just pulling your leg, man, nothing else. And so
Oh, see, somebody is there already. Yeah.
I know the cocktail. This is Kardashian, right? If you don't know her. So Cocktails with Chloe. This is Cocktails with Kura. And so Kura is a mixologist, and he is he has a Instagram account, and what he has built is essentially a domain name, cocktailswithkura.com. And let's go see that. But before I jump into the domain, I would like to just open up my command line, make it a little big to see from a distance, and then I will dig this and find out what its name server is. And you will notice something very, very interesting, something very different from all of you, rest of you. You probably have your domain name from GoDaddy. And what Sridhar has done is moved it away from GoDaddy to a different service called Cloudflare.
Yeah, it's pretty good.
Yeah, it is actually nice. If you look at this service, the same service that I use also, if you look at Cloud Genius domain and find out the name servers, so NS, you will find that I am also using Cloudflare. And you will find that I use Cloudflare almost for every domain that I have. I think absolutely every domain that I have. I think the cloudseminar.com name servers are also on Cloudflare. So that's a different service. It's a free service. It has a lot more capabilities that it provides than what GoDaddy does. And it is free forever, meaning it is not going to charge you next year. So that's something that you may consider, but don't rush into it. Don't have to do it. I'm just saying that he did it, like Sridhar did. The benefit of doing this is that he has now certain capabilities. For example, he was trying to build this website, which I would like to open it up right now here. This website is, the same thing that we know already. Cocktails with Kura on the title, and happening cocktail mixes, and second cocktail mix, and first cocktail mix, and like that. He's basically creating a blog post about drinks, about mixes that he's making, and he's customized it. And you can see that at the top, the URL that he's chosen is not just this, but he's modified it to be www, like Kenny also did, right? If you look at the dig of www, you will find that it is actually a canonical name, just like Kenny did, like www.kennywin.com. Same thing here. www.cocktailswithkura.com is a S3 bucket, which is eventually mapped like a canonical name to this name, www. And what he has also done is, if you dig just the name and find out, it gives you a IP address. This IP address is a representation of the bucket that Sridhar has. Sridhar has two buckets, by the way. One of them is called www.coffeewithkura.com, and the other one is called just coffeewithkura.com. Now there are two buckets. The DNS name here points to the bucket. The DNS name here points to this bucket. This bucket is empty. This bucket has the stuff. The stuff came from Octopress. Octopress followed by the sync tool, S3CMD sync tool. That's what's putting stuff in here. So it shows up when you visit this site. Now what is there in the other bucket? It is empty, except there is a redirect rule. And that redirect rule, what it does is anybody who visits the naked domain, naked, meaning without the www, if you visit the naked domain, it will redirect itself to the one with www. And then the URL will change it to this domain. That's how he has structured it. That's what he wanted. That's what he's able to get through two different buckets with a redirect rule for one empty bucket going to, from this location, it jumps to that location. If you can now see the same idea in here, if you say curl and find out the header provided by the cocktailswithkura.com website, you will see that it is a permanent redirect right there, moved permanently. If you now go to that permanent redirected location, which is this location, if you like to curl that, it is actually telling you that I moved it to this location. So this move permanently is an indicator of that. And that moving is happening because of a redirect empty bucket right there. Now, if you take this domain, but this time curl and find the header for www dot, you will find that it actually shows you the header from the bucket, which actually shows the content. So this is not going to be 301, but a 202 OK header. This OK representation means it is actually rendering something. It is rendering content HTML from the Amazon S3 server. There is a server. This is a serverless setup because you don't have to manage a server, but there is a server right there. It tells you right there, there's a server. So even though it is serverless, there is a server. This is also a server which is basically generating a redirect request. That's the pieces that I wanted to tell you about. And here is how you implement it by creating another bucket and put a redirect rule. You can accomplish these things fairly easily, provided the name service provider supports that scenario. So there are certain good name service providers that actually do a lot, complete capabilities of DNS. Cloudflare is one of them, and it happens to be free. Other people are also good, but they're not necessarily free. For example, Google gives you a DNS. Google Cloud DNS, Amazon also gives you DNS. Amazon has DNS name. They have a custom name for it. They call it Route 53 because the DNS queries happen on port 53. So they named it, the service is called Route 53, which you can see here. Route 53 is the name of a service that Amazon provides, with basically a DNS service. It's also very good, but they charge you money. It is not free. You can use it. It's not expensive. It's like 30 cents, 40 cents per month. It's not that big a deal. Having said, what you saw now is, in this case of, let's say, the dig www.kennywin.com, you will find the same exact representation. You have the domain mapping to the bucket in a canonical name fashion. And that canonical name itself is hosted in Amazon, and that's the IP address. But all that good stuff that we see is basically a query of canonical name on this name, which maps to this longish, boring name that I don't even know how to say it right in one breath. So that's why we have CNAMEs. A new idea that I want to now talk about is this idea called A record. That's the item I want to talk about briefly. The idea of a record, also known as address record, I think many of you already intuitively understand this idea, is as simple as this. If you know, if I just talk to you about the White House, you will immediately know and understand that I am talking about 1600 Pennsylvania Avenue. You already know that because there is an implied translation between this name and this address. That implied translation is done through what is known as our postal system. Postal system is capable of helping people translate the name to an address. That's kind of thing that I'm talking about here when I talk about the A record. That's what happens when you have to get an A record or something like CNN.com. You go dig the domain name for an A record, and it will give you the answer. The answer is going to be an IP address. That's what you will find, like this. Dig CNN.com. Give me the A record. So it gives you that. Actually, it gives you 4 A records. 1, 2, 3, 4. 4 IP addresses. That's for high availability. So you see that. You will also see another thing here. Dig. And then you say cloudgenie.us and give me the A record. So you get the A record and you find only 1 IP address because, you know, we are a small company. We are not like CNN. If you look at same thing, but this time go to Boeing.com. It's a big company right there. you have two IP addresses load balancing each other, right? Same thing again with another company. Let's see this one, A record. And what do you see? How many IP addresses? 8 of them. What is going on? That's the logical question. How come suddenly this same person who thought that he is a small company with only one IP address is now able to show me another domain with a lot of IP addresses? What's the deal? Is that a valid question that you might have? So let me answer that question. The question, or rather the thing that you see here is these IP addresses are actually true. That is exactly what I have, is a highly available, highly reliable, scalable setup, which I have configured because that's what I want to scale out. This setup, this site, the new site I'm building right now is essentially helping me. And I want to set do not disturb here. And there we go. Do not disturb on this machine as well. Okay, so what I'm doing essentially is that I am spending a little bit of money to get a special treatment to my bucket. What happens is, if you have that, you know, that Cloud Seminar site here, this site is actually just a bucket, right? You heard me say that. I showed it to you. You heard me that this thing, where is that? console.aws.amazon.com. There is a bucket called thecloudseminar.com. And in there, I just have a bucket and I'm dumping my static content to create this, this site called thecloudseminar.com. It's basically a static site. However, there are so many different IP addresses here that show up because what I'm doing is spending a little bit extra money and providing some kind of a cover or a wrapper around the S3 item, which is the next idea that I want to talk about. So if you look at this bucket right there, yes, it's a bucket and it has the content in there, and you see that it's properties and it shows you static website hosting, and it has this name that you just keep track of. Let's keep track of that name for a minute. So you keep track of this name here, and here it is. So we know that that's the name. But more importantly, what I would like you to look at is the queries that I go and dig on the Cloud Seminar. What you will find is actually this is not directly mapping like a CNAME to this name. Like that's what you would expect. That's what Kenny and Coffee with Kura has done, right? KennyWin.com and Coffee with Kura. That's what you have done essentially, is created a canonical name record that maps to the bucket itself. That's what both of you did. But in case of this domain, I have not done it that way. I've done it slightly different. What did I do actually? Let's go find that out. So I will go to the domain name server I have, which is in Cloudflare. So I'll go to Cloudflare and see what I have actually done there to help us understand what's going on in terms of the so many different IP addresses showing up. What's the deal? The deal is called Content Delivery Network. And you can see that in the Cloud Seminar domain, if you look at the DNS, and you will find that this domain is actually let me pinpoint the exact one. There are too many records here. So that's the record that I have created as a canonical name. And let's go see what it means here. So what I have actually done is created a canonical name entry like that, but it is not going to that bucket. Instead, it goes to something else. And that something else is this. This is provided to me from a service called CloudFront. It's a different service. What it does is, if you have a bucket here, say in Oregon or in Virginia or some other location, you know, it obviously means that the same bucket is not in Japan and not in Zimbabwe and not in India. And so what if what if there are people in India who wants to access this bucket? That it will slightly be slower for them as opposed to people living in Seattle. It will be faster and quick because they are almost local to Oregon. So they can just go there and grab and open a browser and see the bucket. And boom, it loads up very quickly, by the way. You may have noticed also that this site loads up a whole lot faster than the other sites I have. Like, for example, this one. This one is slow, slightly slow. This one is really, really fast because there is no server on the back end. It's just a static bucket that I serve. So it is one of the reasons why it is fast. But if you want to really, really speed up and make a highly high-end professional grade website, you want to not really expose this bucket directly to your users. Instead, you should provide what is known as content delivery network layer for around your bucket, around your source. This is the source where things are coming from, and I want to provide a CDN layer on top. That is exactly what I have done here. And that's why you have all these multiple IP addresses spread around the globe in the world, all over the world, in multiple locations, where people in other countries like Zimbabwe and India and Japan and wherever they are able to receive the same content from the source, but from an IP address closer to them, closer to this guy, closer to that guy, wherever that guy lives. Content is closer to them. That capability is another storage capability provided by multiple cloud service providers. For example, if you go to Amazon, and you will find that these guys provide you a service called, what's it called? Here, CloudFront. This is what I'm using on top of the bucket that I have. And so I create a distribution, and I say get started, and I provide them an origin. And my origin happens to be the cloudseminar.com, like that. And then I proceed through the finishing steps, and then they'll come back to me with a link like this, like line number 11. That's what they give me back. What happens is, if you go to that link right now, let me just give you that link. I'll just paste that link right here with Slack chat. So you have it. So you can also test along with me. You open that link and you see what you see. What do you see? It's the same site, the Cloud Seminar. That's what I just pasted. Now, if you go and dig that link again, dig the same link, what do you find? The same set of IP addresses that you will see otherwise when you go to this. Same IP addresses, same set. It is basically the same thing. It is a canonical name. If you now read what I'm doing here, I, by the way, pasted a link on Slack chat, so you have it. What I'm really doing is I put in a canonical name, a mapping between not line number 5, but like this. And this item that I have in line number 7 is actually a wrapper around the bucket. That's what it is. So if you look at that CloudFront endpoint, it is basically providing a wrapper to cover the bucket itself, the origin itself. What does that do for me? Is that it makes that content in the bucket globally available, accessible worldwide for a very, very affordable price. Again, pricing is dirt cheap, just like S3, CDN price is also very, very cheap, relatively speaking. It's not super expensive, is what I would say. Now, the benefit of doing this is, by the way, every big company that you see will do it like this. They will use some kind of a content delivery network. There are a ton of them. If you look at CDN, not here. If you look at CDN on Wikipedia, you can find a huge number of service providers that are content delivery network providers. You can see them. It's a long list. There it is, all of them. almost everybody, and all the big companies, all the telco providers, all the cloud companies, they all have their own content delivery networks. I am just discussing one of them right now, which is the CloudFront Content Delivery Network. Google has it, Amazon has it, Microsoft has it. There are a ton of other companies. All the telco providers have it. Akamai has it. And you can read the list. It's here on Wikipedia. So you can read that yourself. But the point is, what CDN really does, if you happen to be living here in the Oregon area, the Seattle area, and you have your source sitting right here, you want to make it globally available, you put in a cover of CDN around this thing, the origin, the source, and make it globally available through multiple endpoints, wherever they are, wherever people are. So what happens is, this guy in India, he or she wants to visit this site. So they type no, there's no W in my site. So thecloudseminar.com, right? Thecloudseminar.com. They type that. And as a consequence, the canonical name resolution will happen, will go like this. It'll go to this CNAME, whatever that blah, blah, D1W0C, whatever that is. It'll go to that location. So it resolve to D01C, whatever that number is, from CloudFront. And that CloudFront itself is the representation you have here on all these endpoints, globally distributed in multiple locations. And what CloudFront is doing is acting like a cache. And so if there is a person in Singapore that wants to access this site, that gets translated to this CloudFront name, which gets translated eventually to the origin. So it will pull the content and reach the Singapore endpoint. That's where one of the endpoints for Amazon Web Services, CloudFront, is actually in Singapore. It is probably not yet in India, or maybe there is in India, I don't know. But what happens is, the first time somebody from Singapore or India or that region visits this website, they will find that even in spite of the fact that I have this CDN deployed, it is still slow. The first user in that region will find that it is still slow. But the second user in that region, like Singapore area or India area, in that region, the second person will find that it is very fast. The second person will actually not even worry about reaching all the way to the Seattle or the origin or the actual bucket where you might have in, say, Oregon region or wherever in the US, that they would not even hit. Since the first person from this area already looked up the site, as a consequence, all of that content from the origin is already here in a local cache. Local cache in the Singapore point of presence, POP. That's the word that content delivery networks like to use. Points of presence. I have so many different points of presence. I have 10 points of presence. I have 8 points of presence, 1, 2, 3, 4 deployed. That's how they count it. So if you have a particular person, first person visiting this domain in the local cache, will get filled with data. And then for the second person who visits that site will not even go to all that, but instead just get it from the local cache, which happens to be in the region in India, Singapore, that region. So it will be very fast. And the second person gets quick responses from your domain or your website. That's the whole idea behind Content Delivery Network. To configure it, you take some origin and then put a layer of CloudFront around, layer of CDN around your origin. And then that's pretty much is the name that you want to map. So your DNS name you have, like www.coffeewithkura.com. You want to map your DNS name not to the bucket, but instead you map it to your content delivery network endpoint. And content delivery network itself will look at the origin and appropriately pull, or rather send content to the recipient who may be asking for it. It's a pull-based model. So people who want to receive content will pull the content, and in that case, the second user in that area will be happy. The first user will think, it is slow. That's going to be the case in every region. The first user is going to be unhappy. Second user, happy. If you change the content here, like you make a change here, for example, and so now we have this red item. Now that red item will not magically appear in every location. So here there will be no red missing. It will be missing. And so you want to make sure that your content delivery network understands that you have changed the origin. You have to let this CDN know that I have updated. And this concept of letting the CDN know that you have updated is called invalidation. You basically are telling that content delivery network, whatever cache you have globally, is now invalid because I have updated content right there. So whatever you have globally, invalidate. Take new one from me. I got the new stuff. So take it from me. I have it. Take it. That's how it will grab and refresh the cache globally. This invalidation process is a button right here somewhere. Where is that? Okay, CloudFront, in the distribution there is a invalidation button that you create like this and click. You can do this through the web browser, you can do this through API calls and whatever other methods, but that's what you invalidate. So you can just click this button and invalidate. So every time when I make a change to this website, I am actually not only pushing new content to the bucket, but also letting CloudFront know. As you can see, I update quite often. I'm doing it quite frequently. The last time I did it was March 31st. And I might have some changes. And so what you will see is that if I go to my source code, where is the source code? Is it here? No. Is it here? No. Where is the source? There it is. Yeah. So I found my source code. Apparently I have some changes. And so I want to see them. What did I change? And if I like the changes, I would like to then send it to my bucket. So this is pretty similar to your Octopress. Pretty similar because I'm using another generation tool. It is called Hugo. I'm using Go language and I'm creating some changes. Like I made a little bit modification. So I want to see my modifications I made. I can see that in my source code control and find out what changes I made from 31st of March until now. And I see that the changes I made is I put a colon there, like a green versus red. There was no colon, so I added a colon. I added a couple of little descriptive items and I added a table. So this is what a change I made. So I add that change. I modified some configuration here. And so that is not, I'm not happy with it yet. So I'm not going to include that change, but this change is okay to go. So I want to send this out. And what you will see is this table about software-defined storage in this section here in the Cloud Seminar week number 1 software-defined storage section. Where is that? Oh, it's so hard to find. Software-defined infrastructure and software-defined storage. In that section, there is nothing underneath. So I want to push new content, and you can see that it is pushing completely automatically as soon as I let it go. What I will do now is through my source control methods, I will say, please push this new content that I have written into GitHub. So I'm sending it to GitHub. And we'll do Git exercises also, don't worry about that. I am basically committing this to GitHub and I'm saying this is the change I made. I see the red and green changes. And I'm saying, please push these edits and push it to GitHub. And that's all. I'll sit like this, and you will see the magic entirely happening all by itself. You will see that. I'll show it to you, by the way. I'll not do anything much other than this push. I sent my changes to GitHub. That's the change you will see. It is happening. What is going on right now, as you can see, is known as continuous integration. You will see that live, and I hope I succeed in that live demonstration. I usually do live demonstration all the time. So I'm going to show you my continuous integration piece, and we will do exercises with this idea later on. But right now, you will see that if I go to my application, which is where the git push has happened, and so it is running that test cycle. You can see that it is starting a new build, started a container. It is checking out the source code, and this checking out that deploy key, and it'll basically progress through this sequence where it will show you what is going on. It is going to test the entire source code from GitHub, make sure that there are no validation errors, make sure that it creates and generates the source code, and it will then generate that source code and then push it to my bucket. And you can see that it actually grabbed AWS API credentials. It is now restoring previously stored work and then proceed forward from that point of, so that it doesn't spend too much time on work that has already been done in a previous attempt on like 2 days ago. And so it is going to build a new site, generate a new site, push all that to the bucket that we have, and then also go to the CloudFront here. And the last invalidation is that time frame, which is 31st of August at 22:27. And you will soon see in like matter of 2 minutes, a new invalidation pop up, which will see that this will invalidate. And as soon as the invalidation happens, this Cloud Seminar will show you new content that I wrote below this section. It will automatically show up as soon as I refresh my browser. So everybody on who's using this website should be able to see a complete end-to-end integration of what I am showing you right now is a couple of ideas all together mixed up. What I'm really demonstrating to you is the concepts together. I have a source, and I take that to push it to GitHub. And from that, it automatically triggers a build cycle and a test cycle in a continuous integration, continuous deployment pipeline, which pulls from here, builds it, tests it, and if it passes, then it will push the content to the repository, to the bucket. And also, after the push succeeds, it will go invalidate the CDN. And then your changes go live. You will see this happening right now. I'll go back to my CI/CD tool, and you will see that this seems to have already created a deploy step, green, and an invalidation step, also green. You see that create invalidation on the distribution with this path already seems to have done. So if you go to compare that with the AWS CloudFront console and refresh the page, you already see that there is a new invalidation showing up for April the 2nd at 16:37, which is kind of right now, 16:38. It just happened, an invalidation completed. As a consequence, this site, you have the software-defined storage and software-defined compute. In between the two sections, there was nothing before. If you now refresh, it will show you some content, like right there. You can see that the software-defined storage has a complete sectional to it and some write-up included. And now I'm still writing on the other pieces. So that is how I am doing it, end-to-end, complete integration, and it goes live. All I have to do is just write stuff and say, send it to GitHub. I just throw it at GitHub, and everything else happens by itself. I don't even have to worry about pushing it to the bucket and invalidating it manually to the CDN, and all of that is taken care of completely hands-free. I focus on writing and push, writing and push. That's all I do. When I feel okay with what I wrote, I send it to GitHub. That's all I do. It just shows up in the website by itself after a complete test. If the test fails, it'll come back to me saying, hey, failed, do something. I had to go fix it, and that's expected. If I make a mistake, it'll fail and come back and say it did not work. So it's not going to push broken code. It'll throw it back to me and say, hey, it didn't work, fix it. That's the entire pipe. Now, the thing that is new here is not just the CI/CD elements, which we will have an exercise on, but I would like you to focus on this coverage between the bucket and a content delivery network, because these are really about storage capabilities in the cloud. We are really discussing storage. So I showed you a CI/CD quick demo, but more importantly, what I want to focus on is the idea that we want to be able to provide a content delivery network on top of your origin. Your origin that we have in our discussions was a bucket, right? You can have any origin you like, any. And any literally means any machine sitting in your garage can also become an origin. And yes, you can comfortably serve the whole world with a high performing website on a machine that sits in your garage for like less than a cheapo box. You can get a cheapo machine for $100, run in your garage, connect it to your Comcast or some other computer, some other internet carrier, make it available on the internet so that people can access it. And then what you really want to do is don't actually directly give it to the people, but instead put a CDN layer on top. So let people come through the CDN. So they will hit the CDN and not hit your cheapo garage box. And you can just run fine. In our example, what we are doing is not setting up a garage box in our garage, but instead we are choosing to put our site in a bucket. So that's a choice. You don't have to use a bucket, by the way. You can use anything, as I said. This cloud delivery, content delivery networks expect an origin or a source. Where do I get my data from? That's what they really need to know. It can be a machine in your garage. It can be a bucket in the cloud. God knows whatever you come up with. Nobody really cares. All they care about is I need to have an origin. So you tell me the origin and I'll provide a CloudFront a content delivery network layer. That's what you see in this example. Oh, where is that? Where to go? This example. Yeah. So line number 7 is the name mapping to the content delivery network, which itself is a wrapper around my origin, which happens to be a bucket. It doesn't have to be a bucket. It can be your home IP address. That's also okay. It works. It works because the load is being borne by the CDN. All the customer load is handled by content delivery network, and you actually, your machines and the buckets that whatever you have as the origin don't get the brunt. The brunt is dealt by CDN. So that's the thing that I want you to do. Now, when you do the exercise and you want to extend the idea, which I just said, you want to create a canonical name network like this. I put a CloudFront entry right there for the domain name, as opposed to putting, let me just do it, for example, as opposed to this 25, as opposed to line 25, which is what you did before. I would like you to do something like the one I describe in line number 7. By that, I mean, here's what I exactly mean. What I would like you to do is go to your name. You might have like kennywin.com, and there, instead of the cloudseminar.com, you want to get kennywin.com, or rather www. And then put in a canonical name mapping to your own CloudFront endpoint that you will receive from CloudFront, and use that instead of using this one, which is going to be a wrapper around your bucket. And don't go directly to like you currently have. Currently you have line number 10. And I would like you to go like line number 7 says. Oh, yes, correct. That's what I would expect you to do as the next assignment for your own website. Now I will change topics to another one related to this before we switch to another topic. So I would like to take a moment and ask questions. What do you understand this idea, what I'm asking you to do? And do you have any questions around this idea, which we just discussed two things primarily from a DNS standpoint. We discussed canonical name records, we discussed a record, and that basically we are able to map it to either a bucket or a CloudFront endpoint and make it even more resilient, more reliable, highly available, globally addressable, and all that. And that's what we just did. The questions on this topic in terms of content delivery network or origin or caching behavior, global scaling, all those, bring up those questions because now is a good time.
Question.
Yes.
So different cloud provider, are they all have similar number of point of presence, or any one cloud provider is better?
Yeah, so we had to go and find out from everybody. Like here is another CDN provider, right? So let's go find out how many points of presence do you have? You have to ask them. And every provider will tell them how many POPs do they have. So let's go ask this guy. This is another CDN company, right? So we'll find out and see how many points of presence you have. So they showed you a picture with a graph, global map of all the dots where they have POPs. And some of them are showing you active, and the black colored ones are showing planned POPs right there. It's a planned POP, black colored. Blue colored are active POPs. So there are lots and lots of POPs globally distributed apparently. That's a nice CDN. I use this one also. They are also very, very affordable. They are $49 per year, flat fee. The pricing is pretty dirt cheap, $49 for first 10 terabytes. So pretty impressive pricing there. You can also estimate how much traffic you have, and depending on traffic, the price will change. So every content delivery network have their own network built in differently. They all behave conceptually the same way, which is to provide a wrapper around your origin point and give you global points of presence for some price. They charge you some price, and these guys charge $49. Amazon charges you whatever they do, and they have, they're continuously increasing their points of presence globally. So this is how you have to really identify from every every content delivery network provider. You have to ask them, hey, how many POPs do you provide? And what is the overall response time? And in fact, you can go and let's see if we can test something here, for example. Where can we test?
Nilesh, one question when you get a...
Yeah. Speak slightly louder. I cannot hear you.
Can't hear me? Come on.
Gustavo, closer to the microphone, please. Yeah, thank you.
Okay, so what are the cons or limitations to using this solution? Is it just the cost?
Cost is one. Extra code is another, right? This is another piece of code you have to introduce. So you need to understand that there is some code needed to make your invalidations work. Right? That's one piece. The third piece, so cost, extra coding in terms of making sure that your CDN is in sync with what you want. If the CDN goes down, we have a problem. So I also understand reliability of that particular service provider. There are other cheaper service providers like, this guy's Max CDN. They give you another one. There are so many of these guys, and some of them are good, some of them are not good. So you have to really understand. They might give you like a $10 CDN, or maybe less than that. I don't know. Is there a good one? Maybe it is good, maybe it's not. I'm not complaining that they're bad. I'm just saying that you have to really identify from like these guys have service providers, the points of presence available, but you have to take it with a pinch of salt. Every provider will be different. So understanding from the pros and cons. The pros are it becomes globally available. Cons are there's a cost. There is some programming involved. There is also the reliability, availability of those service providers. Are they really reputed? Have they shown or demonstrated their past performance? What if the CDN goes bad and you have a big CDN deployed around your infrastructure and CDN goes bad? Now what? Basically your customers are screwed. They cannot access your origin because they are going to the CDN. They're not going directly to you. so they cannot access it. That's a problem. You don't want that problem. So you want to go with reliable quality service providers that have global points of presence at an affordable price and also easy to program. That's the trade-off you have to really worry about. So look at good performance, look at good reliability, and then look at pricing. Pricing cheap doesn't mean good, right? Cheap doesn't mean good. And when I say Cloudflare is cheap, I actually mean that they are good and cheap. That's why I suggested that at least to Kura, I said, yeah, go and take Cloudflare because I found them, they're really, really good. And so cheap doesn't mean good. I just want you to be aware of that.
How is CDN different from, I know Amazon has something called edge locations. Is that the same or is that different?
I don't know what Amazon edge locations you have in mind because Amazon gives you this. So which edge locations are you talking about? Where?
I think they have something called edge locations, which are like servers they have spread around the world. I'm not sure if they're like DNS servers or that's kind of what my question was. It's something similar, I think.
I think they're talking about this.
So a quick Google of it, it looks like that edge locations are used by CDN.
Correct. Yes. These are the locations on the edges of Moscow, and here is your Tokyo, here's your Bangalore. These are edge locations, and CDN points of presence at the endpoints. CDN basically will use their POP locations to provide a local cache to make your users in the remote locations happy. So let's go do some Google searches on what you said about Amazon edge locations.
Sure.
So let's see what they have. Let's see what comes up with. And so the first thing I see is CloudFront. The second thing I see is CloudFront adds 6 edge locations, right? So it is the same thing, to me at least. And you see the third news is announcing additional edge locations in CloudFront. You see that? Even the third news is also about CloudFront, Chicago, Illinois, Frankfurt, Germany locations. Chicago has 2 new edge locations, while Frankfurt now has 6 locations. They're all talking about CloudFront.
Okay, so it's kind of the same thing then.
It's the same thing. I think so. So by the way, just like these guys, every other provider will have the same kind of setup. So if you go to Google Cloud, you'll find something similar. Let's go find them. What do you have? What do we have here? Storage. What do they call Google's? Should be in the storage section. No, I have to search. Search Google for Google services. How about that? So Google Cloud CDN. What does come up with? So they have, there it is. They have a CDN built in and it's called Google Cloud CDN. Pretty similar. Quick start and go to the CDN page there. Cancel. Go to the page and you will find it here. It's in the networking section, apparently not in the storage section. Right there is Google Cloud CDN. Add your origin. Same concept. You give them an origin point, you click. And by the way, here you can mix and match. You can give them an Amazon bucket as the origin. Is also okay. You don't have to stick to Google's cloud to do every single thing or Amazon's cloud to do every single thing. You can mix and match. Totally okay. Certain things are not okay. I'll tell you when it is not okay to mix and match. For example, if you're running an application server and in one cloud and using a database from another cloud, not a good idea. So if you're using an application in one cloud, you should have the database servers right in the same cloud. That's a good idea. But adding an origin from a different location, totally fine. Adding an origin as your home garage, also okay. You can just put in your home IP address and run your garage machine with whatever you have and put a Google Cloud Google Cloud Google's content delivery network around it. That will make it highly resilient. Yes, it will. And they are highly reliable services. They charge you money and they'll deliver the job. They do the job. These guys do it. I've used it many years. Same thing with Microsoft also. They'll do the same thing. So concepts. This is the concept you want to understand. Understand that quality, reliability is important. Pricing is something that you have to pay for it. And then it's a decent service that, you get to create, and it's there available for you and doesn't cost you an arm and a leg. And you get good quality material. So why not take it? So I use it all the time. It's very affordable. Every single site and service that I run for our customers, as well as the one for our own business, are all protected by some sort of CDN, just like this. And you will see this as I demonstrate concepts to you. I want you to do these things on your own buckets and your own exercises, and your own servers that you will set up, and your own serverless setup that you will set up, and things like that. So we'll go along. So I would like you to now ask you to do this CDN exercise also on top of your own bucket. So it will give you a flavor of understanding these capabilities. Additional questions before we switch topics? Okay, looks like there are none. So here, what I want to now do is that we want to talk about this domain that we bought, and that we have understood the ideas of an A record and an CNAME record. So we got that, right? A record is like, Sridhar, and it's a very long name. So Sridhar comes up with a short name like that. Whereas in case of an A record, it is like Sridhar, and the address is, I don't know what, some number address in Issaquah. That's the address, right? So that address mapping is different from a short name mapping. This is a canonical name, a friendly name mapping. Whereas also known as alias, this is an address record entry. So it's a different type of information. There is a name to number mapping as opposed to name to name mapping. And now we will cover a third type of record. The third record type is responsible for transporting email. It is called the MX record type. And it needs to go point to some mail server. Otherwise, your mail will not work. So now, if you look at the domains that we have, that you have, and let's go see Dig. So Dig, kennywin.com for the MX server. What do we got? We got some domain control there. But it is not the answer section for MX. It is for, start of authority record is domain control, which is GoDaddy. That's the start of authority record. But my question was about MX. And the answer section is empty. So the MX is the question I'm asking. Answer, I don't get anything. All I get is SOA. That means if somebody sends an email to Kenny at kennywin.com, that is going to fail because MX records are missing. So we want to fix that. How do you fix that? You want to get a mail server, right? That's how you will then receive email and then send email and things like that. So that's what I want to discuss next and do it. So we'll do an exercise. You know that, Kenny doesn't have a mail server. And I would like Kenny to have an email address like Kenny at kennywin.com. Wouldn't you want that, Kenny? Or do you have it already set up? I don't think so.
No, I don't have a mail server set up yet.
Okay, so we'll set up a mail server for you. How do you do that? You want to basically get a mail server from some company, like open source, ideally. If you can set up open source yourself, that's, I think, a good way. But these days, it is not the most optimal way to set up your own mail server in your office. Instead, there are lots of service providers that already give you email services. 3 of them, Office 365, Google Cloud, Google, they have a different name for it, G Suite. And another one is Zoho. These guys give free trial email services. And I think these guys actually give you free perpetual services. Let's go find out what does Zoho give. Zoho free email. There it is. See what do we get. How much free are they giving you? Apparently business is free. There it is, free. So right there, free for up to 25 users in your company. KennyWin.com, the company, will have up to 25 users for free. Nice. Take it. Take it. Literally, seriously, take it. It's a decent service for free, and use it. So what you want to do really is either go to Zoho, which is like a $0 free service for up to 25 users, or you can get this service for 14 days of free trial, or you can get this service for 30 days of free trial. It's your choice as to what you want to do with experimentation. Again, this is not actual setting up a business, but you can, your own domain, you can set up for your family members, get a free setup here, right there. You could do that. I would suggest that's the route. If I were you, I would go that route. New domain, want to play with it, learn it, and then give email addresses to family with family members at KennyWin.com. Why not? You can. And so do that. I suggest going this way. You can also experiment with these services, but they'll cost you money after 30 days or after 14 days. That's okay. There's nothing wrong with spending money. They're good services, good quality services. In fact, I use both of them. You can see that we have our Dig, Cloud Genius. Come on. Dig, Cloud. Okay, come on. What's going with typing? MX. What's wrong with my typing today? MX. There we go. And so you see that I am currently showing you my MX records, and the question section is answered in the answer section, where it is telling me that this domain uses these mail servers, 5 of them. I got 5 servers from Google that manage my mail. As a consequence, you can see that I go to gmail.com and read my Cloud Genius mail. And there it is. So you can see that something happened. Some news report or some report came from my own site to me. That's what you're looking at. Fine. But that's where the services are running, and I am using them. They're good service. Also good service. I don't know about them because I haven't actually used them, but seems to be okay service. And free makes it really good. I mean, I cannot beat that. So try these services. That's why my goal to you is to let you experiment with MX records so that you understand how email flows properly, really, for real, for your own domain. And then I would like you to send me one email from your domain. I'm not just talking to Kenny, by the way, but I'm just saying with your domain in your name, send me an email. That's the homework assignment, by the way. Nilesh at Cloud Genius. Please send me an email. That's the homework. And I'll just give you some hints about how to make this happen. You will sign up with any of these 3 service providers. There are more, by the way. You have to find out where they are, who they are. And they'll give you a mail machine, a mail server. They will also walk you through and guide you a couple of steps in terms of how to configure your MX records. MX records come with certain priorities. What was the priority number? Depends on the provider. Yeah, there's 1551010. So 1551010, five priority levels. And you have to then specify the addresses of the mail servers here. And they will give you these entries. What do you put here? For example, I received these entries from Google. So I put them. Where do I put them? In the MX record for these priorities. And they'll guide you exactly how to do it for every cloud provider that is worth their effort of using an email service like Zoho, like Google Cloud, or like Microsoft Cloud. They will give you these things and ready instructions on how to consume them. For example, here in the Cloud Genius domain, there, you will see that in the DNS section, if I find my MX record, you will see that I have, if I search for the MX records, I think they are on the next page, probably. There it is. So here are my MX records. You can see the MX record. This was modified 2 years ago, apparently. And here is the priority number 1 and the address from Google. Here is priority number 5. Here is priority number 10. And there are these 5 total addresses that I put in. And once you have these records in place, email starts to flow. How does email flow? Email goes like this. If it is me and on my laptop, and on this laptop, I just send an email to Kenny at kennywin.com. If I just create an email and send, what happens as a consequence is that there will be a query on the domain as to where are the MX records. That's how DNS system will find out where should this email go. From my laptop, I send, but then it goes out and figures out where do you need to go. So it'll go and figure out the DNS records for this domain first and find out what are the MX values. It'll get a bunch of values, 1, 2, 3, 4, 5, whatever, however many are there, Zoho or Google or Microsoft, whatever they have. And then appropriately route that email to that address or one of these addresses, depending on priority number 1, 5, 5, 10, 10. Sometimes it's just 1. Like in Microsoft, they just have 1 address. They priority 10, and they don't have these 5 addresses. They just have 1. That's fine. And 1 is good enough. So that address is where the email will be sent over. On that location, you will have the server aware of the fact that this domain is managed by this service provider. So it will actually welcome that mail. Otherwise, if it doesn't control that mail and there is no domain associated with that service or that cloud email server, then in that case, it will reject that email and say discarded. But when you create an account with those service providers, you're actually letting them know that kennywin.com is running here. So they will accept that email in the system. Now within the system, they will have multiple domains like kennywin.com, and they have cocktails with Kura.com and thousands of people. The email comes in and is destined to this domain. So fine, they will find out how many people have an account on that domain. And there seems to be a person by the name Kenny. So there has to be a mailbox for that person. So they'll take that email and put it right in the mailbox. So next time when Kenny comes in on his iPhone, or maybe another phone that he has, and logs on to the mail server from the service provider, it will look at this Kenny user's account and see the mailbox and dump that email right in the phone. And then you see that in your inbox. That's how email flows. So in order for the email to correctly function, you critically need 2 things. 1, a mail server. A mail server can be obtained from any of the service providers I mentioned before. And second, MX records. Like here, I have them. And Kenny doesn't. That's the reason why a mail doesn't work. So fix it. Get a mail server, put MX records, and homework is send me an email. As simple as that. Simple homework. I hope it is interesting. And I would like to say one thing. I assign homeworks randomly, like out of the blue. I come up with stuff and just give it at you. At least apparently it seems like so. Seems like so. But I would like to say one thing. Don't do the homework. Yes, I just said that. Don't do the homework unless you find it interesting. In fact, you should resist and say no to homework the moment you think that this homework is boring. Because I don't want you to waste time. Honestly, if the homework is not interesting, please don't do it. And actually tell me that it is boring. Because that's how I will improve. That's how I will make the homework interesting to you. And if I don't do that, there's no point in doing the homework. There is absolutely no reason to do boring stuff. You have enough work. Wherever you work on, there is enough work for you. So you do that stuff, but don't bore yourself with unnecessarily silly things like I'm assigning you some stupid homework to send me an email. Don't do that. Don't do homework if you don't like it. Simply speaking, that's how I operate. And what I would appreciate is if you please tell me that, Nilesh, your homework is boring and I will not do it. I think that's what I want to hear. And so please tell me that. Thank you. Thank you in advance for telling me whenever you do, because I will really take that feedback and improve upon the quality of homework to make it actually practically useful and interesting to you. If some homework is not interesting, why do we even have it? There is no point to having it. Well, enough. So you got the point, right? Please don't do the homework if it is boring. Okay.
Question.
Yes.
So SMPT server, that's flowing to MX.
So SMTP is Simple Mail Transport Protocol, and what the exact steps are like this. Let me repeat, and I'll tell you exactly where SMTP fits in. So here is Nilesh, and here is Kenny. Kenny has an iPhone. I have an iPhone. And this iPhone, I will write an email and send it out. When I send it out, it actually uses my SMTP server. This SMTP server looks up the domain name kennywin.com and finds out its MX records. This MX records will point to a bunch of different addresses, which are the mail servers where kennywin.com runs, the mail server. It happens to be in Zoho company, for example. So there will be some zoho.com address, not kennywin.com, but the mail server for kennywin.com point to the MX record, which happens to be Zoho. So this email that goes out from my SMTP server will land in Zoho. Now, Kenny's iPhone knows that his mailbox is sitting with kennywin.com, which is mapped to Zoho company. So it connects to that. And this email goes to Kenny at kennywin.com. So there is a mailbox for this person, Kenny, in this domain mapped to Zoho service, so that this person, Kenny, has a mailbox, and that's where the email will go and sit in the box in Zoho company for Kenny user in the kennywin.com domain. When Kenny's phone connects to the Zoho service, it will pull this sitting email into the phone. That's where the picture comes into play. Now, SMTP service is basically a transport service. It is to send email. When MX records correspond to mail servers that receive email. So the recipients are MX, the senders are SMTP. Got that?
Yeah.
Okay,
Thank
next
you.
question. Next question. Okay, so that's a homework. Now, I will give you bonus homework. Okay, here it is. Here's how it looks like, the bonus homework. I'll show you. It was easier to see than talk. So here we go. Let's see if we have an email from any one of you. Okay, let's see if we have email from Kura. So here is Sridhar. Sridhar writes me an email about something here, right? What does he write? He writes me this email saying, hey, do you have time today to discuss something? He wanted some help. So we talked the other day. So now if you look at that email carefully, he writes me this email, right? He's writing me this email. So I'm going to look at the details, like click. And what do I find here? I find that the sender is Sridhar Kura at gmail.com. I find that the recipient is me. That's great. Date is okay. Subject line, whatever. The critical thing that I want you to focus on is the next two. These two are mailed by and signed by. Those are the two critical components to email that I would like you to be paying attention to. Mailed by is a signal that tells me that this email has been sent to me by gmail.com. That's an authoritative way of sender policy framework identification, SPF identification. When I say SPF, I do not mean sun protection factor, but I mean this sender policy framework. It is a way to validate whether email is coming from the source that they pretend to be coming from. It pretends to be coming from gmail.com, but is it actually coming from gmail.com? Is it actually mailed to me by the Gmail SMTP server? Yes, I can say that because I see the mailed by flag, and that gets generated by SPF. SPF happens to be another record in the DNS system known as the TXT record keeping SPF entry, or rather storing the SPF entry. That's what another type of record you need to have. And if you have that record, it will show you a correct mailed by cocktailswithkura.com. Right now, you see here, it shows you it is mailed by gmail.com. And it pretends to be coming from gmail.com. It is actually mailed by gmail.com. And that validation comes through SPF, which is basically nothing but a text record like that. It will show you mailed by cocktailswithkura.com. You can see this yourself in your own side by looking at emails sent by me. I send you emails occasionally. You may have received emails from me. You can see the same thing showing mailed by cloudgenie.us. You should see that if you have it. If you have any of my emails, you should see this. You should also see the second flag here, signed by. And this is a digital signature originated from the sending machine, the SMTP server, which is actually digitally signing this entry before it sends that email out. So gmail.com is signing it properly, and it shows you gmail.com signed by gmail.com. And this entry happens through another method known as domain key identified mail record, also known as DKIM, that record. Now this DKIM is nothing but another record, simply right there. It is also a text record with a underscore, some key, dot, some detail. I will describe the detail, but it is going to show you signed by cocktailswithkura.com, provided you create a proper DKIM record. A DKIM record is properly signed by your mail server. And SPF is an entry authorizing you or authorizing your mail server to mail your mail. So let's recap this. So it's a little bit complex, and once you do it, you will understand it. And if you find it interesting, you should do it. The concept here essentially is about making sure that your email gets delivered properly. Because there is too much spam going on, and therefore to cut down on spam, these new technologies have evolved. is DKIM and SPF. What these things do is basically produce these flags mailed by from SPF. It's signed by, is digitally signed by the domain key identified mail signature. Let's see this implementation in real life here. Dig. And I'll like to look for the TXT record. And I'll find it. And I see that I have this TXT record. Now, if you go compare it, and just rather I should say, if you look at it in detail, what you will find is that it tells you that it is an SPF record, that it includes all the emails originating from line number 7. Since I manage my mail servers in the Google company, I am saying that all the email that pretends to be coming from Cloud Genius needs to be as if it is coming, sorry, let me say that again. What this record is basically communicating to the world is to let them know that any machine that pretends to be sending an email to you and appears to be coming from cloudgenie.us domain needs to come from Google. And if that is not so, please drop the mail. I don't want that mail to reach the inbox. If it is coming from any other box other than Google boxes, please drop it in trash, or rather, not even trash, just don't even deliver to the mailbox. Don't even let it go. Filter it out, like right there at the door. Unless it is coming from Google machines. And then in that case, you please let them in. Because that's how I'm showing an authoritative way of declaring that it is actually mailed by me, or rather my machines or my domain. So that's the idea. If you decide to create your accounts and your mail servers on Google, this is going to be your record also. This exact string, line number 5, is going to be your record. If you're using some other service like Office or Zoho, you will have something else here. Like for example, this. I don't exactly know what you will have, but something like this you will have. They will tell you what you will put here. I don't know. They'll tell you. But you get the idea. This is the mailed by flag, which is basically a TXT record, letting the world know that you are using that company to send and receive emails so that people will honor. And you're actually asking them to reject everything else. This dash all, meaning please reject every single email that comes from any other box, which is not this. Then reject it. That's the SPF record. Now let us go look at an example implementation of the DKIM record. Dig. I forgot, so I'll go to search. I forgot how to write it. So DKIM record, how do you write it? I'll just cheat and find out the record instead of doing dig query. So I'll go cheat and find out where is my record and just quickly show it to you. Oh, it's a TXT record type. Okay. Yeah, I think I find it. Okay, there it is. So it is google.dig_domain key.cloudgenie.us. That's how you have to structure your TXT record, and you will find an answer. In the answer, you will find a string, which is a digital signature right there. So let's go take this in a notepad and compare what we have. So this is what we have in the notepad. Let's carefully look at what we get. So we have a domain in which we have a question that we're asking, what is the question? And the answer is this. So we ask them this question, put any arbitrary string here, but depending on the service provider. Google is my service provider. And then dot underscore domain key is the syntax you need to have, that exact syntax like that. In case of Google, I'm using Google, but you can actually put whatever you like here. That's not an issue. But this is critical, underscore domain key, followed by your domain. And you have to create a text record. So you can see that this actually is a text record. Which at the end is basically just a public key. This is a public key that I am exposing to the public under my domain key. And this is the this is the entry responsible for people to see that the mail that I am sending or my machines are sending from the Cloud Genius domain are actually, no, not this, this one. Like this is signed by Gmail. You will see something similar. If you go look at any of the emails I may have sent to you, you will see it is also signed by Cloud Genius. Let's see some other example emails I might have. For example, go to inbox, and there is this company called Zoom, right? So it tells me that Jessica is waiting right there. And so that email is, you see that, is mailed by not Zoom. Is mailed by another company, signed by Zoom. That's a valid scenario. You know, you can have a third-party mail service send out notification emails like Mandrill, sending emails, meeting attendees are waiting. So when you came in, I think at 3:52 before the program, before the class started, 4 o'clock, apparently that's what you came online on, and Zoom emailed me saying Jessica is waiting, and it emailed me from this machine, but it is signed by Zoom. So I know that this message is actually coming from Zoom because it is signed by them. They have assigned a third-party service, Mandrill, to send out mails on behalf of Zoom. So let's go check what Zoom settings are for SPF. Let's go find out. We'll go dig Zoom and show me your text records, please. And what do we see? We see that it has a long list of SPF records. Let's go digest what they are doing. So here are the SPF records for Zoom company. SPF includes, they use Google apparently. They use Amazon Simple Email Service. They use some box at this IP address, line number 12. They also use the Mandrill app. They also use them STSPG customer. And they also use Salesforce.com. And they are saying that, you know what, this tilde as opposed to the dash here. In my case, you saw this dash all, whereas in case of Zoom, you're looking at tilde all. So there are differences in the way this tilde is treated compared to the dash is treated. This line number 7 dash. The differences are pretty much that this line number 7 is very strict, whereas a tilde is not so strict. What does that mean by strict and not so strict? So let's go find out what it means. How do you find it? You just read Wikipedia. And it tells you that a minus sign means a mail should be rejected if it doesn't match. A tilde is a soft failure. It is debugging aid between neutral and failure. So it is not going to be rejected. It will still mark as a failure if it doesn't come, but let the email go. So this soft fail is good for debugging, but for actual implementation, I suggest that you use minus, because the moment you strengthen your email, that basically prevents anybody else pretending to be you, trying to send emails on behalf of you, generating more spam, is going to bring your reputation down. To keep your company reputation, it's a good idea to keep your strict policy strict. To fail, if somebody else sends an email on behalf of Cloud Genius, drop them, kill them. If Gmail, or rather not Gmail, Google sends emails out, because I use Google servers, then allow that email. That's the policy. And there are other flags here also, like plus to pass no matter what, neutral meaning I don't care, tilde means I'm testing, debugging, and minus means strict, failure. That's the qualifier you can associate yourself with a SPF record. Like I have done something like that, and Zoho company seems to have done something like this. They have many servers that are sending emails on behalf of. They have their own box in line number 13. They use Mandrill. They have STSPG customer. They have Salesforce.com, and they have Google, and they have Amazon SES, and oh my God, too many servers. But probably they're a big company, so that's fine. Let's see what Boeing does. So we'll go check, dig Boeing.com, and find out what TXT records you have. And you have a lot of them. And you're also permissive. You're probably debugging. Let's go see that. So we'll put that right here. And we find that you have an SPF record, and you have, one, two, I think 2 servers in Seattle, 1 in Phoenix, another in Phoenix. This, I don't know, EWA, where is that? Another EWA server. And you have a permissive policy, a debugging policy. You're not strict. That's the current decisions you have. So you have these many mail servers that send email out when email is coming from, or seemingly coming from, Boeing.com or Boeing.net. These are the servers that are considered to be valid under the sender policy, and everything else is considered to be not Boeing, which is how you describe to the world as to, if the email comes from these boxes, okay. Email don't come from these boxes, you should drop them. That's the signal you're sending through SPF. Let's go find out if you have DKIM also. So we'll go dig, and it's hard to search without knowing the exact string that you may be using, but let's go see if I can come up with something. So I don't know I will succeed with this or not, but domain, I'm just giving it a shot, see what comes up. Probably nothing. Okay, no, I did not get a response. The text response is empty. Answer is empty. The question I asked, answer section is blank, which means you're not using Google, which is expected. You're running your own servers. That's fine. Now, that's the concept behind the 2 things that I added on top of MX records. And the thing that I just said were, creating an MX records lets you send and receive emails. Creating an SPF record, which is basically a TXT entry, which will confirm that you are indeed the company, the machines that are mailed by. And another entry called DKIM entry, which is also a text record under a specific flag called _domain key dot coffee with Pura.com, and you have to put a string there, some string. You choose your string. Dot domain key dot coffeewithpura.com. That will generate a DKIM entry, and this will be the reason why email recipient companies will trust you, because it is going to be signed by your boxes. So you will see these flags. So those 3 things you should do for a properly structured mail system. These things technically are optional, but not anymore. I mean, I don't call them optional anymore. They used to be optionals. They're now not strictly not a requirement, but I would absolutely set them up. It doesn't make sense to not setting them up. If you're running a proper mail service and you expect your mail to receive and you expect your mail to land on the recipient's inboxes, wherever you're sending it to, you need to have these things. If you don't have them, there is no guarantee that your mail will actually land in the destination when you send an email. Even if you put these things, you will still not a guarantee that your mail will land in the right spot in the destination computers, in the destination mailboxes, even if you do these things, because mail delivery and delivery of a mail to the targeted audience depends on 100 other things, not just these two things. They're very important though, but they are not complete and sufficient conditions. They're necessary conditions. So to make it sufficient condition, we have to discuss a whole lot more about email deliverability, which is a different topic. It's a mixture of science and art because it also involves how you write. If you're sending like millions of emails, you have to really be paying attention to how you write emails and how you send and what keywords you use and what keywords you don't use, because there'll be spam filtering techniques that many companies apply that will basically drop your email. It will not reach your destination. So what's the point of having a mail system that doesn't deliver? You will see this issue with Bellevue College, right? Yeah, they send an email to Boeing.com and the email doesn't reach you. Why? Do you know why? We can find out. I'm exposing the dirt. Let's go find out. So here we go. Bellevue College.edu. Let's see what text records they have. Oh, they're using Outlook. So they're using some SPF records now. That's good. But let's see whether they have DKIM. I don't think they have DKIM, but let's go check. I'll see some emails coming from Bellevue College to me, and I'll find out if they have a signature there. So where is the email from Bellevue College? Right there. And it is now signed by, but again, it is not signed by Bellevue College. You see that? That's a problem. That's one of the reasons why. You want the signature to be the company that is sending an email, like right there. And you see that they have not set it up properly. That's one of the reasons why emails don't flow properly. It is being sent from Bellevue C. on Microsoft.com. This is Office 365 implementation, apparently. Office 365 will give you something like that. By default, you have to change it to make it align with your domain. If the misaligned entry like that, Boeing company will reject it left and right. You have a misaligned entry, don't like it, drop it. Sometimes you don't receive email from Bellevue College. This may be one of the reasons. I don't know. This is very likely one of the reasons. There are many other reasons, by the way, but this is just one. Okay. Questions on this topic before we move forward with another topic? Any questions? I have one question if you don't have one. Is this interesting? Is this useful?
Yes, I think it's interesting.
Yeah, it's interesting.
Would you do this or not? Okay, I told you. Will you implement it? Would you send me an email with SPF mailed by, signed by, with your domain?
We'll try.
Try.
Yeah, I'll try.
Yeah, try is good. If you get stuck, don't worry. Just call me. I'll help you. We'll make it work. Absolutely. We'll make it work. So I'm not leaving you high and dry and do it yourself. That's not the idea. I want you to succeed. And that's why we are giving you the homework. Doesn't mean that you do it yourself and I'll leave you hanging. That's not my idea of homeworks. I want to actually receive an email from you to make it successfully work for you. So we'll make it happen. We do that every single time to help you do what you want. This is the reason why I do the boot camp. It's not to give you random homework and make you feel bored about, this guy gives you bad homework. That's not what I want. I want you to enjoy this and do it. And if you get stuck, call me. Literally, really call me, email me, text me, go to the on the discuss site, post something there. I'll immediately respond, like here on that site. Okay, let's switch topics unless you have questions on this.
Break, please.
Break. Okay, break. Good, break. Hey guys. Okay, let's keep forward. I hope you're back also, and we'll proceed.
Yeah.
Okay. So what I want to do next is to understand some of the ideas regarding securely connecting with cloud services, right? So that's the concept. What I'm also doing is looking at our top level view of what we are dealing with: storage, compute, and network. We are focusing on S3. We discussed about CloudFront as content delivery network. And these are the elements that are kind of new, conceptually new to the enterprise use. You already know how to use file servers. You already know that. So I don't need to walk you through about how to use file servers unless you want us to experiment with that, in which case it's a different story. And similarly, I understand you already know and understand use of SAN or block devices, block storage. I think you already know this. So that's the reason why I am not doing any exercises on these aspects of storage. These are new object storage. So we experimented with this with a bucket. We created some static site. We put that here. Now I showed you briefly about CloudFront, which is kind of trivial to implement. And we also experimented with DNS and mapping it to CloudFront as a CDN as opposed to mapping it directly to the bucket. So I would like you to do that homework. We also discussed DNS and MX and SPF and DKIM records to get the email flowing properly. So those things we will do another homework. But what I'm now doing is switching away to this compute capabilities in the cloud. We discussed storage a little bit. Unless you want us to further dig deeper in certain capabilities in the storage area, I will go do that. But otherwise, I want to switch over to this compute segment, where we are able to define compute capabilities through software. Software-defined compute is what I would focus on next. And so from a compute perspective, what you're really looking at is actually very simple to understand. And that idea comes in a picture fashion, very, very simply in this sheet, where you can see that you can scale a type of machine depending on how much money you want to spend. Like, 1 GB machine, you get for $5 per month. So you can scale it up by spending more, and you get a 4 GB machine, and you spend more, and you get a bigger machine like that. So that's how you can scale, and you can programmatically select the size of the machine you want. Now, in order for us to get a machine, we need to do a couple of things. For example, very first thing is we want to connect to it. Like, in order to connect to a machine in a secure fashion, we need to do some kind of an authentication. And authentication is somewhere you are basically telling them that you are indeed who you claim to be. I'm talking about authentication, where you have a name, a person, an ID, some kind of identity. Typically it is regulated through username and password. You already are familiar with this concept of a user password. But in case of authentication, when you're dealing with machines or computers, to be specific, and you want to connect to a remote computer, you can use a username password, no problem, it works. But it kind of gets boring when you want to type the password manually over and over again. If you're doing it like 100 times, 1,000 times, that becomes a really, really cumbersome approach to handling passwords manually. So you want to have a somewhat of an automated fashion of securely authenticating with a remote collection of computers. And that's where, when you get tired of typing your passwords, you then stop using them. So what's the alternative way of authenticating is what I will now describe to you. And that idea comes from a PKI, public key infrastructure. PKI infrastructure has an ability to generate pretty similar to these things. user and password, is the idea of a public key and a private key. There are two keys that you will generate, and you will use them in making sure that you are able to authenticate yourself to a remote computer and are able to connect to it and do whatever you want with it. So that's the method that we will be using, the PKI based, signature based methods to generate a pair of keys. And that key pair generation leads to these two things, a public key and a private key. I'm assuming that you are somewhat familiar with this thing, and please tell me if that's not the case. Also, please tell me if you know what PKI is and what public keys, private keys are. Probably, I think you may have used it, but I don't know, so I need to know that. Please tell me that you have used it or haven't, both ways. So typically when you generate this key pair, it leads you to two files. Those two files are typically named this. This is the private key, and this one is the public key. They're the two files that get generated, get created when you generate a key pair. And they get to sit in a location in your computer, in your workstation. They sit in this location. This is where it sits. Let's go there. Let's go to that location and find out where it actually is. So in the terminal, you will find that I have this location where it is in that ~/.ssh location is where these keys are sitting. You will see that I have these two keys, IDRSA pub and IDRSA. Those two keys are sitting right there. But this is Macintosh. So let's go to the actual virtual machine that you are using, and we'll go see the same thing inside there and find out what do we have. So here is the virtual machine starting up, and I will now create a new key pair inside that machine. These steps that I'm going to follow are documented somewhere in this site. I'll point out exactly where it is, and I'll give you a link to you in Slack chat. So you have a link coming up right there in Slack, coming up right there. That's what I'm going to be looking at, or rather that's what I will be generally following in terms of steps. Now, if you look at this computer and you go to that folder called ~/.ssh, it is a default place where keys are stored. In that location, you will find that I have nothing except this example file. This file we'll come to get to it in a couple of hours. We'll use it. But right now, if you see, apart from that file, I don't have anything else in that folder. The folder is ~/.ssh. That's the folder in my home location. My home location is represented by the letter tilde, and which is where I am currently, which is this location. And if I go underneath that location to the .ssh folder, that's where I land in the ~/.ssh folder. That's where I will have nothing right now, or rather, nothing right now, except this one file, which is an example that we will use later on. That means there is no key there. So I want to generate a key pair. Generating a key pair is fairly simple. You will follow a simple command given in that Slack link that I just pasted, and that is this command. That's how you generate a key pair, which basically means you type this. It means I'm selecting the type RSA key, I'm selecting a bit depth of 4096 bits, and I'm storing my result in that file. That's the actual action you will do. You can do it this way, or there are other ways to generating keys, based on the same command called ssh-keygen. That's the command. You can simply run this command also, just like that, and say SSH key gen, that also works. It will just generate a key pair, like go enter, 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 enter. It generates a key pair right there. I have an IDRSA private key and IDRSA.pub public key. They are available to me. I'll go and examine them. So I'll go and first of all, cat the ID_RSA.pub file. This is the public key, which means you should share it with everybody. It is supposed to be given out to people, to computers, to services, to cloud service providers. That key that looks like this. It will, of course, vary from person to person, machine to machine. But this portion is the key. And the rest is a comment. This is not technically a part of the key, strictly speaking. This is a comment identifier. And this portion is the actual public key. So when you cat it, you should see the key, the public key first. And you should give it to everybody, whoever needs it. However, this is the private key that you should never, ever, ever share with, even with your boss. Don't share it. I just shared. It's a bad idea. But I just want to show it to you, see how it looks like. And so the private key begins like this and ends all the way up to this point. That's the private key. You're not supposed to show it to people. And since I showed it to you, I am going to delete it. And delete both public and private. Both are gone. Now I have nothing except this example file, which I will use later. Okay, so that was a quick way to generate a key pair. I will now go do the slightly more complex ways of generating a key pair, which is this way. So I'm specifying that I need a RSA cryptography method. I need a 4096 bit depth and store the result in this file. So I'll just run that command in one shot and I will have a key pair ready. It's asking me for a passphrase. I will say no, nothing, enter. And again, enter. And I'm done. My key pair is now ready. The key pair is available there. It's a public key, sorry, private key, and this is the public key. I can cat my public key, no problem. Show it to you. You will notice that this public key is slightly bigger than the previous one because I am using a wider bit depth, 4096 bits. As opposed to earlier, the bit was smaller. I think it was 512. You see that the private key is also small. This new private key that I have is going to be big. Let's go inspect that. And it's going to be a little bit bigger than the previous key because there are 4096 bits. It begins here. And it is, of course, a little bit bigger key in size itself. So it's difficult to decipher. And that is because of the bit depth, 4096 bits. And that's how you generate a key pair. Now I have generated a key pair, but I have showed it to you, so which means I'll delete it again. I have these keys. I'm going to remove them one more time. And generate one more time. When I generate a key like this, then I have the key pair again. And I need to provide this public key to everybody, like cloud services, for example. So I will do that just now. What I'll do is I'll cat that public key and give it to a cloud company like that. I'll grab this from here all the way up to this point. I'll leave the comment out. I'll copy it. And I will not show you the private key this time. And now I will go to this cloud company and I say, you please take my key, like that. So in the securities section, there is a place to drop your public key. And so you say, hey, you take my key. So this is the workstation key pair. And so I will provide it a name, workstation, and paste the public key and add it. That's how DigitalOcean will know that I am using this key pair for which I have given them my public key. I still keep my private key private, and I'm not going to give it to anybody because I will use it to authenticate myself when I connect to a variety of cloud services. For example, this DigitalOcean machine that I'll create now. And my intention is to use this private key that I have to connect to the DigitalOcean machine that I will create without having to use a password. What I did already is provided them this public key so that they know that I will be using the corresponding private key. A couple of things to observe here is that in these two files, if I somehow accidentally delete this file, like accidentally I delete this public key, ouch, I lost my public key. It's not a problem. You can always regenerate your public key out of the private key that you have already. So I kept my private key safe. I can reconstruct my public key very, very effortlessly by running something like this. It will regenerate my public key using my private key that I have already, because I did not destroy my private key. It's still with me, and I can just comfortably come here and say, hey, please. Oh, sorry, what did I do? Break, Control C. And what I want to do is actually generate a public key using my private key that I have already. So like that. And there we go. And so it generates the public key right there. And what I want to do now is to save it into that file which is available right there. I'll redirect the output into id_rsa.pub. And then I will see that content in the file. You see that file gets created again right there, and it contains the same key that I accidentally lost before. Now, the challenge is if you somehow manage to delete this private key, there is no way on the planet that I know of that you can regenerate a private key that you accidentally misplace. Which means if you lose the private key, you are dead in hot water. You're screwed, basically, practically screwed. That's not what you would like to have. So keep this key safe and protected. That's the second type of key that we just discussed. The first type of key pair we saw was this AWS secret key and AWS access key. You saw that before in Octopress example. So that's one key pair from Amazon. This is the second type of key pair that you generated yourself. There's also another type of key pair, by the way, very, very similar, that Amazon will generate for you. So you go to Amazon Cloud, or other Amazon Cloud, and go to EC2 section. And here you will find that this EC2 section, you can make note of the region you are in. So I like to play in Oregon today. So I go to the Oregon region, then I select the key pair section, but I have nothing. So here I can either import my key pair and say, give it my key pair name, like workstation. And then here I paste my public key, my public key content from here. So I copy this and paste it in that location and import it so that Amazon knows that I have my workstation key in the right location. So that's a good thing. That's one way to handle and tell Amazon that you got my key now, you got my public key. That's great. Same we did with DigitalOcean. They have my public key right there, workstation. But Amazon gives you one more method. In this method, I don't like to use. And it's a philosophical reason why I don't like to use. There's nothing technical about it. The reason is that I just said that I just told you that, don't give your private key to anybody. That's what I said. And now in the other method of generating a key, you're generating a key pair by hitting the blue button, which is not what I like. Nothing wrong with it though. Nothing technically wrong. But when I create a key pair, I get to have a key pair generated for me. I call it Amazon generated key. And then I create. And so boom, something happened. What happened is it downloaded something for me. Like this key pair is now available to me. I can open it and I can see it. It's right there. And yes, I accidentally showed it to you again, but that's the key pair. And who generated it? I did not. Amazon did. That means they have a copy. They might have a copy, who knows? That's a bad idea. And that is the only philosophical reason I does not like the idea of having somebody else create me a key pair. That's not what I like. So since I don't like it, delete it. The Amazon generated key pair, I don't like to use it, so I cancel it. I said, no, I will use my own generated key pair. And I know for sure that I have never ever shared my private key with anybody. So I know that that is indeed the private key that I have, and they have the public key copy. And I don't like to use the blue button for philosophical reasons. I know that Amazon will not keep a copy of the private key, but I just don't like the idea. So I don't use the blue button, but instead I import key pair and I give them my public key instead. That's just me. Don't take it with too much. There's nothing technical about it. It's just me. I don't like the concept of somebody else generating a key pair for me, because it's a philosophical debate you can have whether they're trustworthy or not. Amazon is trustworthy, but it crosses my philosophical way of thinking, so I don't like that approach. Doesn't mean that you should not use it. Actually, it's a nice thing to have an easy way to generate a key pair, and so you just click and you get a private key there. That's a good one. Nothing wrong with it, but I don't recommend. Don't use it. Instead, do it the right way, which is you control your destiny. You control your private key, not let somebody else like Amazon control your private keys. Okay, having said, let's use them. So I'm going to use my public private key pair that I have with Amazon and with Google. With DigitalOcean, there's two clouds. You can add Google, so no big deal. Any cloud. And now let's go create a machine, like right there, and create a droplet. And we'll tell them, you know what, give me an Ubuntu machine and give me a cheap $5 machine, $5 per month. So really cheap. And then give it to me in San Francisco. And then, by the way, use the workstation key that I just gave you, right? That key, not this one. This is the one in Macintosh. I'm not using that one. You can actually have multiple keys. No big deal. You can have multiple. And just leave it to one right now. For right now, just leave one. So one key right there and create a machine. So it gets created. Machine is starting up. Now, since we started this machine we selected a key pair to begin with, the workstation key, and I have it here in my workstation, and the key is kept safe right there in here. I will be using that key, the private key, to connect to the DigitalOcean machine that I have created. It's starting up. I will be getting an IP address soon, and that IP address will be this one. I copied it, come back here, and say, come out of this folder, by the way. Don't work in the .ssh folder. This is not a good place to work. You come out, cd, say tilde. That's a good place to work. Go to home. That's a good place to work here. And so don't work in the .ssh folder. As you will see, you will experiment with a bunch of things as we go along. There'll be more exercises. And I don't want you to work in random places that you don't know what you're doing. So if you don't know what you're doing in the .ssh folder, come out of it. And now you do whatever you like here, SSH. And then we know the root as the username for the machine in DigitalOcean Cloud. So DigitalOcean Cloud gives you a login name as root. So we use the root at symbol followed by the IP address we got. What's the IP address we got? This. From DigitalOcean. And then we have to pass along a private key. So we put a -i flag and give it a path to the private key located in this location. And our private key is that one. That's how you structure a command. SSH root at IP address with a -i flag and then the path to your private key. So this is where we will authenticate ourselves as the private key owner and then attempt to connect. Connect to what? Connect to this machine here in DigitalOcean. We just have that machine created. It is ready and running. And we want to connect to this IP address. And we know that DigitalOcean documentation tells you that the username is root. That's why we have the word root right there. That's a general structure of how you would connect. I'll put that general structure of connecting right in your Slack chat. So it looks something like Slack chat looks like this: SSH root at IP address followed by -I. This is how it looks like when you want to connect. Just remember to change the IP address. That IP address needs to change depending on whichever machine you're connecting to. Now back here on the workstation, we are going to connect. And one thing that you will notice as I connect is that it'll ask me a question. The question basically is, it means, do you know what you're doing? That's the real question they're asking. This SSH connection method is asking me this question when I press enter, and you will read the question. Let's go read it. So I enter, and then it asks me this question. It says, the authenticity of the host at that IP address cannot be established. It means, I don't know what you're doing. Are you sure you want to do this? That's the real question. And yeah, we are sure that we are the ones that created that machine just now. So it is the right IP address. And I would like to say yes to it because I know what I'm doing. I'm not randomly connecting to another machine that I don't know, because I know this IP address. I got it just now from DigitalOcean. So it's okay to say yes. And when I say yes, you will see something interesting happen, which is not super obvious unless you know where you're going to see that. So I will show it to you, something interesting happening right here. In another terminal, I will open the same folder .ssh, and you will find that currently I have a config example, which is the example file. We'll use it later. I have the private key and the public key. That's it. But as soon as I say yes to this guy, I will find something else in this side popping up. Now let me say yes to this guy first. And it does something, and it just connects to that DigitalOcean machine in San Francisco, Ubuntu, and all that. That's nice. But something happened on this side. Let's see what happened. We have a new file popping up. The file is called known_hosts. Let's go see it again carefully. That's the file, known_hosts. If you now, on this side in DigitalOcean, we are connected, and we say exit, come out of it, back here. And now attempt to connect it once again. The same detail, same exact everything, and you will find something interesting this time. I'm again typing the same exact command like the last time. SSH root at IP address, same thing, and then enter. And you will find that this time it doesn't ask me this question about, are you sure what you're doing, kind of question. It just shuts up and connects. No questions. Do you know why there are no questions? The second time.
Because
It's no host.
host is already created.
Right, the host is now known. We know about it. Host was already created, but now we know about it. This hash that is showing up here is an entry corresponding to the knowledge of the existence of this machine. It is a known host. That's why the name known hosts, right? So now you connect another machine, let's say in Amazon Cloud. You go to Amazon and say, I need to create a new machine. So I go to EC2, launch an instance. And by the way, this time is going to be a little bit complicated. I'm going to rush through it, and we'll do this multiple times, so you will really understand it. Don't worry about it. I'm speeding up a little bit, but just watch me. So I'm going to T2 micro machine, review and launch. or rather previous, and go cancel it. I need to select a couple of things also, which I forgot. So Ubuntu server and T2 micro machine, configure details, and this looks okay. And add some storage, and that's fine. And add some tags, and that's also fine. And add a security group, use the default security group, and then review and launch. And when I launch, I will have to select my workstation key pair, which is already populated there, which is nice. And I say, okay, now launch an instance. So it is going to launch an instance, a new machine in Amazon Cloud right now. You can see it's getting ready. It is pending right now. It has no public IP. It has a public IP address right there. So the public IP is available, but the machine state is pending, which means it is going to get ready soon. And as soon as the machine becomes ready, we will see that we should be able to connect to this IP address just fine, provided we come out of it and then type SSH root at, not really, not root. It is Ubuntu at, because Amazon Cloud machines that are running Ubuntu operating system like to use Ubuntu as the login name, followed by the @ symbol, followed by the IP address, followed by the -i flag .ssh/.id_RSA as the private key. And that's how you will type once the machine becomes running. And it is running right now. So you should go back here and say, okay, now attempt to connect to it. And on this side, you still have that known host file, which contains only one entry. Because this Amazon host is not yet known. So if you connect to it, it says, are you sure what you're doing? And I say, yes. And then it connects. So if I now cat my known host file one more time, you will see that there are two entries. The second entry came along, which is a hash corresponding to the Amazon machine. The first entry was a hash corresponding to the DigitalOcean machine. Now both these machines are known to me. I can now connect to the DigitalOcean machine, and I get connected. I come out of it. Then I connect to the Amazon machine, and I get connected, and I come out of it with no questions. The reason is these two machines are now known hosts. Great. Let's now connect back to DigitalOcean. In here, you will find on that machine in the remote location, we have this folder. And in that folder, we have the folder called .ssh. Same folder, but on the remote computer. In that remote location, we have a file. What is it called? Let's find out. The file is called authorized keys. It has a very nicely structured naming convention. We have authorized keys here. On the local computer, we have a known hosts file. Let's see what the authorized keys file contains. It contains what? That looks familiar to me. What is this?
That's your public key.
Correct. It's the public key right there. See, it matches the public key. So what it did was that DigitalOcean, we gave them the public key. So they injected that public key right in that file in that location. So now our key is an authorized keys key, meaning it is an item in the list of keys that are authorized to access that machine. So now if you happen to have a public key that you would like to give me, what I would like to do is add your public key to this file here. And once you do that, you should also be able to successfully connect to my DigitalOcean machine, provided your key is also authorized. You can do that simply by pasting your public key in this location where I have this command that I'm pasting, which you will be using, by the way, to connect to my DigitalOcean Droplet, provided I add your public key to the authorized keys file, for which I need your public key. So I would like you to please give it to me so I can add it here to this file. And then that will grant you permission to connect to that machine. So anybody? There you go, Jessica. Thank you, sir. Thank you very much. I grab your public key. What I'm doing now is adding your keys to the authorized keys section. And here is your key added. And I will exit. And now we'll see if Jessica can succeed in connecting to this machine. Let's go see if Jessica, can you please try?
What's your IP?
You see the Slack chat?
I'm in.
Okay, there we go. So we can see Jessica right there. This is Jessica's machine, Jessica's computer. And the first entry is my computer. Looks like Jessica also uses Comcast.
Yeah.
So, yeah, that's how it works, right? So you have the .ssh authorized keys file contains two public keys authorized to connect to this machine. So now Jessica can handle this machine, and she can even she can create a mess. She has root logins, root permissions on that box, so she can do whatever she likes, full control. So she can even kick me out by editing. By removing this key, she can kick me out of the machine and just eject me if she wants to. But that's the idea. The point is to understand that the authorization happens through this file, which contains a list of all the keys authorized to connect to that machine. And similarly, as a similar concept on the other end, here is a list of all the host machines that are authorized to connect to from your workstation. So on the left half is a list that contains all the hosts that I know in that file. And in this half, in this file, this file called authorized keys contains a list of all the keys that are authorized to connect to that host. So it's a similar but counter topic of similar type. Same concept, two different styles. Known hosts, authorized keys. And that is how you connect. You connect to any machine out there which has a public IP, you just go there comfortably. Questions on this before we change topics? No questions. Wow. That's fine. So there are other instructions here about how do you connect to a Windows machine remotely from Linux. That's also a method you want to if you want to play around, you can do that. That's written down here for you if you want to experiment. I'm not in the mood of touching Windows, so I'm not doing it. But if you're interested, we'll do it. I just don't use Windows anymore. I gave up on it a long time ago, 5 years ago. So that's just me. But there are ways to connect to a remote Windows machine using a Linux box. Of course, Windows to Windows connections happens easily with Remote Desktop Protocol, RDP, or also known as, what's it called? I think it is called mstsc.exe. If you know that, you understand this, do you? Or maybe you don't call it that way. What do you use the name for this thing?
Yeah, that's correct.
Yeah, it's called Microsoft Remote Desktop Connection. That's the name in Microsoft. That's what they use, RDP, Remote Desktop Protocol. That's how you can connect between one Windows machine to another. But if you have no Windows machine and you still want to connect to a remote Windows computer, then like SSH in Linux and Macintosh and Unix, there is a thing in Windows called WinRM, which is not very popular, not very commonly known, but is a valid protocol. Windows Remote Management Protocol is pretty similar to what you have in SSH. Like we just used SSH to connect to a remote computer. You can also use WinRM to connect to a Windows remote machine through command line PowerShell. No problem. It works. In fact, that's the method that I have written down here. WinRM, Windows Remote Management, using WinRM to connect to a remote Windows VM. That method is written down. You want to follow it if you like, but your choice.
Do Linux command prompts have the WinRM protocol built into them?
No. That's why you have to follow this approach, right? So the good thing is PowerShell itself is open source and is available on Linux. So that is now available right there. You can see Microsoft brings PowerShell to Linux and OS X. So you can install this package if you like, or just go to GitHub and grab the source code. This is Microsoft PowerShell available on Linux. So you can that way do whatever you like. That's another possibility. But again, it's up to you. It's your choice. The choices are available. If you like it, go take it. Don't like it, skip it. Totally up to you. Now these machines are available, as you know. So what I would like to now do is say, for example, this T2 micro machine that I have here that is running. I'm looking at it right there. And what I want to do is run a site with a server, right? That's the next exercise. We ran a site without a server. This time I want to run a site with server. So let's go to that server, which is already running right there. And I want to connect to it using this IP address. So I have it here and I will go to that remote location. First of all, I will exit from this location. And then I will go to the Amazon computer. And there is my machine. It's a server. And I want to run a simple site there, right? Really simple site running there. So all I need to do to make a really simple site up and running is to install a web server. So how do you install a web server? You go like this. And it will install an Apache web server. And what do you have at the end? You can go to that IP address and open it up and find out that you have nothing yet because the Apache is not set up yet. Now we'll see that Apache is finished. So we should now see that website again. And what do you see? You see Apache is working. Great. That's how it goes. Simple thing, right? I just went there, installed a software, and the machine became a website like that. But this is an IP address. So what I want to do now is to map it to a domain, to a DNS name. So what I want to do actually is go back here and look at our domain name. Say, for example, coffeewithpura.com. And I want to create a new domain like test.coffeewithpura.com, create an A record and put this IP address. And if you can do this, Sridhar, that will be awesome. Because when you do that, when you set up this record in your Cloudflare, what I will be able to do, and all of us will be able to do, is go to the test.coffeewithpura.com and find out Apache web server. That's what we will see. So we want to see that. Can you help us in creating that? So the full domain name is not KWK, but Coffee with Pura. So just want to make sure that it's clear to everybody else. It is not Coffee with Pura, but Cocktail with Pura, or Cocktails with Pura.com. So that's the domain we want to visit, and we want to say the same site. We can enable that by the fact that Sri will create a new DNS entry for a new A record with this IP address. That's what I'm expecting Sridhar to do. And when Sridhar does that, we should be able to see that site.
So
right?
I should do in my
Cloudflare.
Cloudflare.com.
Yeah. You create a Cloudflare entry with test, pretty much like this. So you go to Cloudflare, and then you go to your domain, you log in, and then you go to your domain, for example, and go to DNS and create a new A record type with a name test, and then put in the IP address. and remove the orange bubble thing. You don't want the orange thing. We'll talk about the orange thing later. This orange thing, you remove that. And so you put in this IP address right there, like that, and remove the orange. You don't want orange right now because this is a Cloudflare CDN. So it's another content delivery network provided to you for free from Cloudflare. Yes, it is also free. CDN is free from Cloudflare.
So I should add a record, right? Add a record.
Add a record in a record, and that should do it.
And in the a record, I should put a HTTP
No, just like this. Test and a number.
test. Oh, okay. Test and the number. Can you ping me the IP address?
Yeah, it's there. I'll put it in Slack chat. It's still in Slack chat.
I have not connected to Slack.
Okay, no worries. I'll text you. Here it is. Oh, no. Here is the IP address in your text message. You got that? Or rather, I'll just create a test IP address. Testing 1, 2, 3.
Yeah, I got it now.
Yeah. So here I'm going to create a new record for myself called testing 1, 2, 3, and that should do it. So I'm adding a record, and now I have testing 1, 2, 3 created. I will just open testing123.cloudgenie.us, and what do you see? The same page. As soon as Kura is done doing it, we should be able to see the same thing, just like that. We should be able to visit this site as soon as Kura does it. Kura is done with it.
It's done, yeah.
Okay, so we click on test, and it shows up the same thing, right? So we now have 2 different DNS names pointing to the same server. So we have a server in, let me get my pen working. Okay, so what we have now is a box in Amazon Web Services that has an IP address, and I created testing 123.cloudgenie.us mapping to the IP address with an A record, and we have test.cocktailswithkura.com mapped to the same IP address. And they both show us what is running here. What I did here is I just set up what? Apache. It's a simple website, like silly looking a default website like that. Not a big deal. Just a simple server running, showing something. That's what you're looking at right here. And we have two A records, one from testing 1, 2, 3, one from test, both pointing to the same IP.
So Naresh,
Yes.
so the command you run to install the Apache, is that provided by Amazon or is something you create by yourself?
Ubuntu. It's a Linux thing. It's not my thing. Let's see what I typed. I forgot. What did I type? I'll recreate that. So I'll just type it in Slack chat. You'll see what I'm doing. It's a Linux thing. It's a sudo apt update. That's what I think I typed, apt-get update, and sudo apt-get install Apache 2 server. That's what I typed. And then it installs Apache server. So that's what I ran on the box. And you can do the same thing on the other box. Like we have the other box here. Like this is the Amazon machine. We come out of it, and then we go to the DigitalOcean machine, and we run the same exact thing, like exactly the same thing like that. Give me a second. I think my dinner has arrived and there's nobody to pick up. So hold on. Hey, I think you're the dinner person, right?
Yes.
Yeah, we are home. Come on in, drop it. We are home. Just ring the bell. Drop it off.
Sir, hang on.
Huh.
I don't know where your house is. The GPS, it takes me to an address that's not your house. It's the road behind your house.
So go to the other side. Go to the other side and you have to enter.
I tried. Okay.
Uh-huh.
I'm here, and my problem is, does the houses here have the address on them? And I've been driving up and down to
I saw your car. Listen, I saw your car. It's in the cul-de-sac at the very corner. That's what you will find it. You look for the stones that will have the number.
Okay, so just turn around and come back.
Yep. Yes, please. Thank you. So what I was doing is the other machine I have, I will run the same exact command, and you will see the other machine also becomes a web server. So right now we have the IP address right there. We'll copy it, go to that site. We'll see that it doesn't have anything right now because it is not installed. Right? This is a DigitalOcean box. It has nothing. We just created a box. And now in that same box, I will say apt update and apt install Apache 2. Or instead of Apache 2, I will install Nginx this time. It's a different solution, different server. And let it run. It will run and install Nginx in a matter of few seconds. We should have Nginx running on that same IP address. So that is setting up currently, and it should finish your Nginx setup in 3, 2, and 1. And I think we're almost done. So not yet. It's doing it. And so yeah, DigitalOcean seems to be slow a little bit today. Yeah, so it is done setting it up. Now we should be able to see that same IP address will now show us Nginx. Let's go see that. Open it up. And what do you see? Nginx server running a static, no, not static. It's actually a full server running a site. It's just basic default, but it is a site. And that is the IP address that I want to now map to another DNS. So what I would like to do is go to my Cloudflare, and instead of the testing 123, I will create one more entry. Like for example, I will create testing 321, and then say give this IP address, and remove the CDN. We don't want to use CDN right now, so we remove it, and then add another record. The record is created. I can now go to 321.cloudgenie.us, just like that. And I should see Nginx in 3, 2, 1, go. And here it is. Oh man, I'll tell you what's going on. It's not going to work with my domain because I've configured it in a different fashion. So it did not pick up yet. We have to wait for it. The propagation needs to finish. It is not going to work on my domain because I have configured my domains to be slightly different with Kubernetes. So you will see that propagation will take roughly about a couple of hours. And then this 321 will show up. Without that, you have to work with the IP address because that's how my configuration of my domain is set to deal with everything is running in the Kubernetes cluster, which I run in the Google Cloud. So it is configured to programmatically go, everything goes to that location. That's what you're looking at here is the default backend showing you is actually coming from the Kubernetes cluster, which doesn't know what to do with this testing 321. So it is telling you 404 error because it doesn't understand what to do with testing 321 because it doesn't know. Amazon knows, or rather I told Cloudflare, but Cloudflare propagation is taking time. If you try it with another domain name, it might work. It's not a big deal as such. But I have configured my domains to all go to my Kubernetes cluster, which is one of the reasons why it is taking a little bit of time for the propagation to finish. And it did not. Maybe I'll try with a different name, it might work. So testing 321 did not work. Maybe I'll reduce the TTL, the time to live value. I will shrink it to 2 minutes and see if it picks up in 2 minutes. I think it should pick up. In 2 minutes, it should pick up, I hope. We'll come back to it in a matter of 2 minutes. Until that time, let's go recap what we just did. Here, what we did is a couple of different types of things. First thing, we played with our key generation methods. The thing is called SSH keygen. That's how you generate keys. You can generate keys by default in shorter width, like 512 bytes or 512 bytes, or I generated 4096 bytes. So it's a very, very long key. we had, as a result, we had a ID_RSA file and an ID_RSA.pub file. This is the public key. This is the private key. You can generate a public key using your private, but you cannot regenerate your private key no matter what. We also use this same public key and we gave it to DigitalOcean. We gave it the same public key also to another cloud company, Amazon Web Services EC2. And then we created two boxes, one with these two clouds, right? We got an IP address from here and another IP address from here. We connected to these two boxes and we found out that the first prompt is asking you, do you know what you're doing? Question, which is basically creating a new entry about hosts that you know. And that entry is stored in a file called /known hosts. That's where it stores the entries that you know. And on the other end, on the remote side, there is a list of keys that are authorized to connect. And that is stored in the remote location in a file called authorized keys. And that's what we also saw. These are two important aspects to connecting securely. Then we had these two IP addresses that we got. We were able to install Apache software on one of them and install Nginx software in another one. We both gave us a default site. So we got a default from here and a default from here. They look different, but they are both valid sites. We then mapped this to testing123 and also to test.coffeewithkura.com or cocktails with Kura. Oh man, I always make it coffee with Kura for some reason. And then we mapped the other machine IP address with testing321 and we failed. It will succeed in a matter of minutes. And the failure happens because I have configured my domain to all point back to Google's cloud by default. And so let's see if the 2 minutes have elapsed and whether the testing321 will correctly point to Nginx. There it goes. So it fixes. It fixes because I reduced the TTL value in my DNS control panel. TTL is the value, which is the time it takes for the DNS entry to propagate and old values expire and the new values will pick up. So this value that I just put for 321, testing 321, I set it to expire old values in 2 minutes and get the new values in place and globally propagate it. Some of the modern DNS control panels give you a very, very low TTL value, like 2 minutes, for example. Whereas GoDaddy's will talk about at least like a 30-minute, 60-minute type of delay. It's a slow servers. Low TTL values are good for quick, expedited updates to DNS records. That's where this TTL value comes into play. If you're using Cloudflare, they also have a content delivery network built into it. That's what this orange symbol looks like. You want to use it, but you want to use it properly after you understand it. That's why I was suggesting that you don't enable this connection, the orange connection, right now. Don't, to begin with. Once you understand what's going on, you can, of course, use it. That is also free service available from Cloudflare. Okay, let's see what else we did. We then, did I miss anything that I say? I think not. I think I at least summarized what I discussed. Okay. So one thing to remember, when you create these machines out in the cloud, like I just did 2 of them, it is a great idea to kill them, like actually terminate them. How do you terminate a machine? You want to click on this, go to actions. It's kind of difficult to find, but instance state and then terminate. That is something that you have to remember to do it. If you don't do it, do you know what happens? you have to remember to, hold on, I think my settings are broken. Let me go fix it. If you don't terminate the machine that you're done doing an exercise with, what happens?
You have to pay.
Charged.
You will get a bill. And you don't want to receive a bill for no reason. It's okay to pay them money when you're using a machine, but when you're done using a machine, you should terminate it. That is one of the most important things you need to remember. And there is nobody to remind you, because the cloud service providers will be happily collecting your money. And they don't want to remind you to shut this down and terminate. So it is your responsibility to actually go back here and destroy the droplet. Literally destroy. Where's the destroy button? Right there. Destroy the droplet, like that. There is a red colored button, destroy, and you say, yes, kill it. That's when the bill stops. So you remember to do these things. I destroyed my DigitalOcean droplet. I also destroyed my Amazon machine. It is shutting down, and then eventually it will extinguish. After 1 hour, it will disappear from view. It takes 1 hour for the view to disappear. It'll still say terminated. It'll say that it is terminated, but it will still be visible to you, like as dead body. The dead body will disappear in 1 hour. So that's the thing to remember. Anytime, so it says terminated right there. The dead body will go away in about some time. So yeah, just remember that is a dead body. You don't have to worry about it. It goes away. Okay. Now what I want to do is to introduce you.
Question. So is there a recovery plan? So I know it's a gone, but is there a recovery plan?
No. No.
Okay.
There is no plan.
Okay.
So see, we are talking about cows, right? Was it Sridhar saying? Sridhar asking?
Yeah.
Okay. Yeah. So Sridhar, you may have missed the cows versus pets discussion, right? I think that's the reason why you're asking that question. So let me give you a very, very simple way to understand. I think you were not there the first day. So that's the reason why. So let me just illustrate this idea. So where is that? Cows versus pets. So let me identify what to read. And you should read this section. So here we go. Yeah, pets versus cattle treatment. So I'll go click that link for you and give you that link to read in your Slack chat right there. So read that. I'll describe this idea to you briefly.
Yeah.
So the idea is, if you have a puppy, do you have a puppy?
Mm-hmm.
Yeah. So if it falls sick for some reason, what do?
Take to a doctor.
Yes. That's what the picture says, right? You take care of the puppy. So that's exactly how you think when you have a data center in your company and you have servers, you have a server going bad. What do you do with the server?
Or take a backup and get a new server or something.
Yeah. You try to fix the problem or take care of the machine, right?
Yeah.
Whereas in case of a cloud machine, what do you do?
Okay. So you just, that's it, kill it.
Yeah. There is no recovery plan. You don't want it because you can always regenerate one, right? So it's easy. So that's how you should think. And so that's the idea that I want you to think about when it comes to cattle versus pet. So you can always use the cattle to milk them and use for meat, and you get rid of them at some point because they're disposable entries. They're not like pets. So just think different. That's the point that I want you to remember. When you destroy a machine in the cloud, there is no recovery plan because you programmatically create a machine in the cloud. You can always programmatically recreate another machine, no problem. Mm-hmm. And in fact, you will see as we start to grow in complexity that you will be able to just dynamically on demand generate a resource that you need for your customer, for your application, all up and running with just one line of code that you execute. It builds the whole thing. You don't have to do these things manually over and over and over again. At the initial stages for the first few sessions and maybe some more, we'll do stuff the hard way. We do stuff the difficult, slow, and boring way to understand what's going on. But the moment you get the point, I would like you to automate. I would like you to reach a point where everything is completely automated. So you don't have to do these things by hand. Yes, I tend to do it by hand, but I don't like it because I am actually doing it to show you how to do it for real. And then once you understand the idea, I want you to automate stuff. And yes, we will do automation exercises. In fact, whatever we are doing right now in the subsequent sections, we'll do it the automated fashion. In the very soon, in the DevOps section, we'll start automating already. What time is it right now? 6:53. So we don't have enough time to actually cover a new subject, new topic right now, but I will actually discuss a couple of things for you to think about for the next session. So I'll maybe briefly discuss that. So here we go with our whiteboard. And I'll grab my pen again. There comes my pen. So in the pen, in this whiteboard, what I'm doing is we talked about storage and compute and network, right? The three things. We did some exercises today with this. We started machines, connected to it, examined security, understood key pairs, and set up some servers, created A records, and saw something running and felt happy about it. Now, what I want to do now is to switch over to this section the next time when we meet. Now, this is the hardest for us to really comprehend because there is nothing to see. And it's all conceptual as to how things connect to each other. So something that I would like you to understand, which I think is very intuitive, and I will relate this to you in a very simple fashion so that you can actually understand it fairly effortlessly. You will see network capabilities, just like you saw storage in the cloud, you saw computes in the cloud, or compute instances in the cloud. You will see some network capabilities also pretty soon. This idea is something that you can understand in your home network setup already. For example, you might have some kind of a router, like I have this router, right? You might have other routers in your home. For example, this thing. Oh, no, not that thing. Google and then router. So you see, routers look like this. So many of you have routers like that, don't you? Do you have such a thing? Please tell me yes.
Yep.
Okay. You have also such a thing called cable modem. Do you? Probably. Or you have a DSL modem, one of those things. So what I'm basically describing to you is that in your home setup, you are very likely to have a connection of some sort from an independent internet service provider. They give you some kind of a pipe and they will bring some cable or some DSL line or some optical fiber channel or some kind of connection to bring you to your home. The first thing you will put there is a modem that will convert this pipe into an Ethernet. And that's where you will receive a public IP address for your home. Right? That's what you typically have. Most homes have it like this. Now, do you connect your laptop directly to the modem? Do you?
You can, but you typically don't.
You don't.
Yeah.
You can. Yes, you can, but you don't. Do you know why you don't?
Because if you need to connect more than one device, you can't.
Yeah, that's one problem to solve, is that if you have more than one laptops, how do you then connect that laptops, all of them, to the same Ethernet cable? You got only one cable. So you want to have multiple connectors, but that's not possible if you just have one connector. And so you need to have some other method. That's one problem. It's a good problem to solve, and yes, that's why you don't connect directly to the modem directly. There's another big reason why you don't connect directly to the modem. It's a very big reason. It's a security reason. The security reason is, I think, the more important reason why you don't connect directly to the modem is because when you connect your laptop or desktop to the modem directly, you are sitting right on the public internet. You have a public facing IP address. And you don't want that, because then you are vulnerable to public attacks. Public, like, bad, hackers from wherever they are can hack your laptop, because the laptop is accessible on the public internet. So you want to have a layer of protection. You don't want to connect directly to your modem, but you put another device. That thing is generally called a router, but it has many, many capabilities. And one of the more interesting capabilities it has is a network address translator. And what this does is not only gives you multiple outputs, so you can have multiple computers connected and multiple wireless computers also connected like that. But all these guys are hidden behind this protection. Is called network address translation. This is something that we would like to talk about. You may have seen that your IP address in this machine or this machine or these is typically something like 192.168 dot something. That's very common, right? Have you noticed that? Did you? Anybody ever noticed the IP address?
Yeah, I've seen it.
Yeah.
And usually your access point's 1.1.
Whose access point?
Well, the like your router usually.
Yes, in US, yes, it is 1.1. In other countries, it may be different. Like in Australia, it is .254, something like that. So it depends on the country's convention, but that's an optional choice you can make. What I'm really trying to say is that there is this idea which is defined as an RFC, which is what I just pulled up, is the reference to the RFC 1918, which is defining a private network. It is different from the public network. And so all of our homes and all of our offices are typically private networks. We don't want to expose our machines directly on the public internet. So we use a NAT device, which is a part of our router, to create a private network for ourselves in our homes, in our offices. That's what this private network is, what I'm talking about. And it gives you these addresses. Like this is the one I just mentioned. Is the range of addresses that are allocated to a 16-bit block address space in a private segment of IPv4 address space. That's common. These are also valid numbers. 172.16 and in this case 10.0.0.0 all the way. Like in my example, I think I have a 10 dot address. So you can see that my address is a 10 dot address showing up here. So I use a different subnet, but most people have the 192 address space. I'm using a different one. That's different idea, but concept is the same. I just am in a different block, different range of addresses. And this is what you do in a private network. And so what happens in the example that I'm going to bring up in this concept, like storage, compute, and network, what we need to do is like we saw in our examples, like, we just did DigitalOcean, and we'll just wrap up very quickly. So stand by. Amazon Web Services. We got an IP address, and we just connect to it, and we ran a site here and a site there. And that is all a bad idea. Because these are machines that are getting a public IP address. Ouch. Another public IP address. Ouch. I am exposing my machine directly on the public internet. Ouch. Bad idea. Don't do that. That's what I'm trying to drive to you, to your point. The point is, just like you don't put your laptop directly on the modem, you don't put your machines that you create in your cloud directly on the public internet. It's a bad idea. I hope you understand what I'm saying. And I will explain to you next time why it is a bad idea in a much more clear fashion. But I just want you to take away this concept, which is very simple. Your laptop, your cable modem, or your DSL modem, and your router. Your router you have here, and your modem you connect it like this. You don't connect it like this directly, because this thing provides you a private address space using the network address translation capabilities that are built into your router. So you want to protect your laptop from bad people. They exist on the outside. They are attacking you constantly. And I'm not kidding. They're attacking all of us all the time. I'm not kidding. In your home, you are getting attacked. And in my home, I'm getting attacked. In my cloud machines, I'm getting attacked all the time. You can see it, and I'll show you live logs as to how attacks are coming. And you will examine and understand. But the bad people exist, just like good people exist. They exist, and they will attack you. So that's the reason why you don't put your laptop directly connected to a cable modem, because it's going to be giving you a public IP address. And therefore, in your cloud machines, you don't get a public IP address if at all possible. There are some cases which you have to have a public IP. And in that cases, we'll take precaution, and we'll do something else, like put a NAC device or put a router-like structure. We'll build these things as we go along. But key takeaway to remember in the networking section is getting a public IP and putting your servers directly on the public internet is generally a bad idea. Generally speaking, there are some cases which you have to do it. And so we'll understand that detail. And at this moment, I am going to stop recording. I hope I was recording. Was I?
Yeah, looks like it.
Yes. So I'm going to stop recording. Thank you. There we go. Stop recording.